Evaluation too can play a very important role in the iterative loops in this analogical reasoning process. One can use several different methods for doing evaluation. In the robot that can walk on water, for example, we can do a simulation, or we can build a physical prototype. If the evaluation succeeds, then well and good. We can encapsulate the target problem in the solution as a case and store it in case memory. But if the evaluation fails, we may need to revisit transfer and see whether we want to transfer some other knowledge, or revisit mapping and perhaps align things differently, or revisit retrieval and perhaps try to retrieve a different source case. As an example, supposing that the evaluation shows that the robot that we designed for walking on water is a little too heavy. In that particular case, we may change the problem specification and retrieve a different kind of organism that perhaps is a little lighter. Let us suppose that we evaluate the design of the robot that can walk on water and find that the design is a little too heavy. In that case, we can go back to the transfer stage and see whether we can transfer some other relationship that might make the robot a little lighter. Or we can go back to the mapping stage and see whether we can align the source case and the target problem slightly differently so that we can transfer a different relationship. Or alternatively, we can go back to the retrieval stage and try to retrieve a source case, a different kind of biological organism altogether. Thus, we see that the process of analogical reasoning is not linear at all. Instead, it can have many different kinds of iterations. Analogical reasoning continues to be an important topic in AI research, and biological inspired design is becoming one. We provide several readings for both topics in the class notes.